Okay, kids, we're back here and we're talking about electric power. Now, power is a word you've seen before when we were talking about energy way back in chapter 4. We learned power was how much energy was transferred in a certain amount of time, and it was measured in the watt. Go all the way back to chapter 4 here, the measured in the watt. So, um, you also hear this word watt when you're talking about electric power, like, oh, my microwave oven is a 1,100 watts, or my hair dryer is 1,500 watts. So we want to see how power, a concept you've already talked about, the unit watt we've already seen, how is it related to electricity? So we want to talk about electric power. So let's first remind ourselves of the equation that defines current. How much charge goes by a particular spot in a current in a certain amount of time. There's the equation for current. I'm going to rearrange this equation like so. Same equation, just rearranged. Then I'm going to remind you of the equation for voltage. Voltage is how much energy is being carried by a charge, or how much energy change occurs per charge at a source or at a load. And I'm going to rearrange this equation. I've just rearranged it in blue. Now what I'm going to do is I'm going to take these two new blue equations and I'm going to combine them. So where we have change in energy is equal to voltage times charge. The voltage remains, but charge Q, I'm going to replace it with I delta T. So I have the energy that is used by an electrical device, for example, a light bulb, is equal to the voltage through that light bulb, across the light bulb, I should say, the voltage across the light bulb, the current through the light bulb, all multiplied by how much time it is on. And that'll tell you how much energy that light bulb or any load uses. Now what I'm going to do is I'm going to divide each side by time, and I get delta E, change in energy over how much time it takes, is equal to voltage times current. Well, kids, delta E over delta T is our old friend power from chapter 4. So power, the power of a particular load, light bulb, motor, speaker, you name it, is equal to the voltage across it times the current through it. So that's a good first step, and here's your first equation for power. Next, we're going to use Ohm's law. Remember what Ohm's law is equal to? Voltage is equal to current times resistance. I'm going to rearrange this, and I'm going to get current is equal to voltage over resistance. And I'm going to remind us of the equation we just came up with. Power is voltage times current. So what do? Well, we take power and we take out the voltage part and we replace it by I times I, R, current times resistance. So out goes the voltage from this equation here, and in goes I times R, and we get this equation here. Power is equal to current times resistance times current again. Well, I times I is just I squared. So another way of calculating the power through a load is the current through that load squared all times the resistance of that load. There's your second equation for power. Similarly, now we're going to take this equation here again. Power is equal to voltage times current, right? And we're going to replace the current, and it's going to equal to V over R, voltage over resistance. So look, the V stays this time. See, power is equal to V, it stays, but I gets replaced by voltage over resistance. And we have a third equation for calculating the power in a load. It's equal to the voltage across that load squared divided by the resistance. So there we have it. One, two, three different equations for calculating power through a or across a load. The other thing we want to look at in this section is the cost of electricity. So let's remind ourselves of a few things. Power is equal to amount of energy transferred over time, and we learned way back in chapter 4 that the unit for that was a watt is equal to a joule per second. We're going to rearrange this equation. So energy is equal to watt times second. Well, That's fine, but usually when we measure how long we're using an electrical device, like a TV or hair dryer or a microwave oven, in our day and age, it's usually measured in hours, so not seconds. So it becomes a watt times a second. Also, in our situation of electrical energy and electrical power, a watt is a pretty small amount of power rating. So usually it's measured in thousands of watts. So kilowatt. So kilowatt hour. And lo and behold, you have a new energy unit. And the new energy unit is the kilowatt hour. And that's how your home is being charged by the electrical distribution company uh, how to charge you for the electricity you use. They don't charge you in joules of energy. How many joules did you use this month in your home for electricity? No, they charge you in kilowatt hours. And here's how that unit comes about. Now, how do they figure out how much money they should charge you? Well, the cost of electricity is equal to the rate of electricity. And it's about 0.13 or 13 cents for every kilowatt hour of energy you use. So that's the rate times how much energy you use. Now, a rate is something you've seen before. It's similar to gasoline, right? $1 per liter. Well, here it's 13 cents per kilowatt hour. And then you have to multiply it by how much energy you use. Now here's the example in the textbook. Calculate the cost of operating a 4.0 times 10 to the 2 watt spotlight for 2 hours a day for 30 days at a rate of 9 cents per kilowatt hour. So the first thing we're going to do is take the power, which is 4.0 times 10 to the 4 watts, which is basically 400 watts, and we're going to convert it into kilowatts. Well, 400 watts is zero point 0.4 of a kilowatt. 4 over 1,000, right? 400 over 1,000. So now we've got power described in kilowatts. Really important you do that. Then the time. Well, it's 2 hours per day times 30 days. So the amount of time it's on is 60 hours. So it's in hours, really important. It's got to be in kilowatts for power. It's got to be in hours for time. Next, how much energy is used? Well, you just multiply the two of them. 0.40 kilowatt hours times 60 hours, 24 kilowatt hours. This is the unit we use for energy, the kilowatt hour. We don't use joules when you're being billed for electricity. Then calculate the cost. The cost is equal to the rate times the energy. Well, the rate is 9 cents per kilowatt hour. The amount of energy you use was 24 kilowatt hours, or it's $2.16. Now, this is for the electricity. If you take a look at an electricity bill, and you should, okay, they also charge you to deliver it. And then there's a whole other bunch of different service charges and this special charge and that special charge. But we're only looking at the electricity itself. All right. So look, today I got some videos for you to watch. I hope you watch them. There's this video lesson, there's reading from the textbook, and then there's some homework to be done. So have a great day, and we'll talk to you soon. Bye-bye.